line. So let's see where these fall into place. In the law that describes how light changes direction as it enters a lens, the important angles are the angles the light makes with the line perpendicular to the surface of the lens at the point of entry, angles A and B. We'll go to the figure in a minute. This line is called the normal to the surface at the point of entry. In a profile view of a lens, the normal is a line perpendicular to the tangent to the profile curve at the point of entry. Implicit differentiation is often used to find the tangents and normal of lenses described as quadratic curves. So there's the way they're talking about. Here you got your nice little curve. You have a nice little tangent line, and there it is. The point of entry of the ray comes in, and then it turns. And so we use the tangent line to find our point of entry, and then our normal line goes through it. Not to find it, but to identify it. That way we can put our normal line through, and it's perpendicular there. So that's that normal line that comes straight in, doesn't curve once it hits, where the light ray will come in and then curves. So they're just kind of showing that this is what the purpose of implicit differentiation even is. Okay, so in this one here, find the equation of tangent and normal lines to the given graph by x to the fourth plus x squared y squared minus y squared. As a point, radical 2 over 2, radical 2 over 2. So in trig, we would know that this is a 45-degree angle. So on this one here, I'm not going to move anything around because this is going to give me dy dx. This is going to give me some version of dy dx, and that's the only one that won't. But why move the one? It's not going to make that big a difference. So x to the fourth becomes 4x cubed plus, and my derivative of x squared y squared. If u equals x squared, u prime equals 2x. If v equals y squared, then v prime is going to be 2y dy dx. And then we had to put it in the format u prime v plus v prime u. So 2x plus 2xy squared, 2xy squared. And this way is going to be 2x squared y plus 2x squared y dy dx minus 2y dy dx equals derivative of constant is just 0. Okay, now keep in mind that we don't have to do anything beyond this for our derivative. We're looking for, we gotta have, they want the equations of the tangent and normal lines, which means we're looking for slope. This is where I get to go. Remember, we use m for slope. So what I'm going to do is I'm going to plug in square root of 2 over 2 for all of my x's and y's, and for dy dx, I'm going to plug in m. So this is 4x cubed, so square root of 2 over 2 cubed plus 2 square root of 2 over 2. Now I'm going to ask you this one. If x and y are the exact same values, do I have to write it more than once? Or can I just simply write it as square root of 2 over 2 times, let's do it this way, square root of 2 over 2 squared plus 2 times square root of 2 over 2 squared times square root of 2 over 2m minus 2 times square root of 2 over 2m equals 0. Yeah, that kind of got scribbled in there. Whew. It's a matter of cleaning these up. And one of the things I want to point out to you is that this guy here, square root of 2 over 2 cubed, is the same as this guy here. So when I go through the math, hopefully you won't go, wait, what did you do there? Okay, so I have 4 times, and if I multiply this out, I'm going to get, let's do a little side work. Square root of 2 squared is just 2, and 2 squared is 4. So I'm going to get 1/2. That's this guy. but it's 1/2 times square root of 2 over 2, which is going to give me, in the end, square root of 2 over 4, plus 2 times square root of 2 over 4, plus 2 times square root of 2 over 4m minus, and I'm going to look, since everything else is kind of left in there, I'm going to keep this one here, is 2 square root of 2 over 2, we'll have to fix that one, m equals 0. Keep in mind we are trying to solve for m, but I have a lot of square root of 2 over 4s, so I'm going to make this guy a square root of 2 over 4, because I can combine these now. 4 plus 2 is 6, so I have 6 times square root of 2 over 4 plus, actually I'm going to leave these two alone. That reduces to make that 2, so I get square root of 2 over 2m minus 2 square root of 2 over 2m, still equals 0. Combine these two guys, so I'm going to reduce this one too. This is going to be 3 over 2, so this is 3 square root of 2 all over 2 minus 2 minus 1 just gives me square root of 2 over 2m equals 0. Let me move this over, so I get negative square root of 2 over 2m equals negative 3 square root of 2 over 2 multiplied by negative 2 over square root of 2, negative 2 over square root of 2. These guys cancel out, I'm left with m, and the 2's cancel out, the negatives cancel out, and the radicals cancel out, and we're left with 3. Don't forget, 2 negatives make a positive. All of that work, and we got slope is 3. Unless I made a mistake. I really hope I didn't make a mistake. That was a lot of work. That was a lot of work. And this is the unfortunate part. We can't put that in the calculator because the calculator is set up only to do x or y, not both. So, tangent line. This is definitely going to be the easy part. So we have y minus radical 2 over 2 equals 3 times x minus radical 2 over 2. There's the tangent line. And a normal, the only difference is our slope. Y minus radical 2 over 2 equals negative 1/3. Don't forget to take the reciprocal. X minus radical 2 over 2. All of this work was for this. Now, being me, I want to go back and look and make sure I didn't make a mistake there. So I am going, well, you won't notice it, but I am going to pause this so I can look at it real quick. Okay, so I sat to the side and I tried this one again. Still got 3, so I'm happy with the work. Okay, next problem. Find equations of the tangent and normal lines to the graph given by x squared minus xy plus y squared equals 7. We have that product rule sitting there again. So x squared, derivative of x squared is 2x minus, if u equals x, u prime is going to be 1. If v equals y, then v prime equals dy dx. So u prime v is going to be just y plus, because remember, it's u prime v plus v prime u. I threw the negative on the outside, so I'll just distribute it later. Plus x dy dx. Plus 2y dy dx equals 0. Got to distribute that negative through, so I get 2x minus y minus x dy dx plus 2y dy dx equals 0. Okay, remember dy dx just stands for slope, which is just m. So I'm going to start doing substitutions. There's my x, there's my y. So 2 times x, which is -1, minus y, which is 2, minus x, -1, m, plus 2 times y, which is 2, m, equals 0. Do our math here. 2 negatives make a positive. So 2 times -1 is -2 minus 2 plus m plus 4m equals 0. So we get -4 plus 5m equals 0. Add 4 to both sides. We get 5m equals 4. So m equals 4/5. So m equals 4/5. Let me write my point down. That's -1, 2. And we can answer the question. So, tangent line. Y minus 2 equals 4/5 times x minus a -1. And our normal, y minus 2 equals negative version of the reciprocal, 5/4 times x plus 1. And we're done. And you can see, even though the one step is calculus, finding the slope, I guess we can leave it under the terms of calculus, even though it's a lot of algebra. There's all of your work. Once you got there, finding your normal and tangent lines were quite simple. Okay. Whew, and another one. At least we only have the one product to do. So if u equals x squared, u prime equals 2x. If v equals y squared, then v prime equals 2y dy dx. U prime v plus v prime u. So we get u prime v, so 2xy squared, plus 2x squared y, 2x squared y, dy dx equals 0. Now we can do a lot of substitutions. So I'm going to put -1 in for x, 3 for y, and my dy dx I'm going to change to m since we're looking for slope. So this is 2 times -1 times 3 squared plus 2 times -1 squared times 3, m equals 0. Yeah, we can see that that first problem was probably the more difficult of the ones because of the radical 2/2. So let's clean this up. 2 times -1 is 2, times 3 squared is 9, plus 2 times -1 is just 1, times 3, m equals 0. So I have 18 plus 6m equals 0. 6m equals -18. Subtract 18 from both sides. So I get my slope to be m equals -3. There's my xy point. And now we can do our tangent and normal lines. Tangent y minus 3 equals -3 times x minus a -1. And normal, one thing is different. Change the sign and do the reciprocal so we get just 1/3 x plus 1. There's our tangent and normal lines. So the last thing we have to look for is if we have higher order derivatives. Actually, I think there's more behind this than that. But anyways, doing higher orders. So they want us to find the second derivative. Okay, fine. First derivative, 2x plus 2y, oops, don't forget the dy dx, equals 0. We do have to go through the process of solving for dy. So I'm going to get 2y dy dx is equal to negative 2x. Subtract the 2x on both sides. Divide by 2y. And we get dy dx is equal to negative x over y. Anytime you have a circle centered at the 0 at the origin, you can get negative x over y as your derivative. Okay, but they want the second derivative, and that's the first derivative. So now we write, okay, so I have dy dx equals negative x over y. Quotient rule. So I'm going to have u equal negative x, so u prime is negative 1. V equals y, so v prime equals dy dx. Yes, even though we're doing the second derivative, this guy doesn't have dy dx on it, so it's just derivative of y with respect to x. Okay, and don't forget quotient rule is u prime v minus v prime u all over v squared. So if I u prime v, I get negative y minus, and this way here is negative x dy dx. And by the way, we have this at this point now. This is d2y dx squared. Okay, let's go ahead and fix this, Don't forget that this is over v squared, so y squared. So I have negative y. Yeah, we have to do some cleanup now because you don't want dy dx in there. So you have negative y plus x times negative x over y all over y. Okay, notice in your numerator you need a common denominator. So I'm going to multiply, I'll even change pins for you so you can see this. I'm going to multiply by y over y. That way I have a y here. So I'm going to get negative y squared plus a negative x squared times x squared. All of this is over y. But that's all over y, so now I have a common denominator. I can bring this guy up once I have a common denominator. Now I want you to watch really closely what we got going on here. Because if I throw the negative out, I have x squared plus y squared all over y squared. But go back to your original equation. Your original equation said x squared plus y squared equals 25. So d2y dx squared is equal to negative 25 over y squared. Your third derivative, if you were asked to do a third derivative, would be a piece of cake because you lost one of your variables. Hence the reason why you would want to clean it up and not leave it like this or this, because you don't want to have to deal with more than you have to. Do a little algebra, clean it up, make it look nice, make it look pretty. Now they don't always clean up this nice. This was a nice one. Okay, let's try another one. No product rule involved in this one. It's kind of nice. Even when we do the second derivative, we won't have a product or a quotient going on. So this one here, derivative 2x cubed is going to be 6x squared. And 3 times 2 is 6y dy dx equals 0. Now with the 6's in here, we can go ahead and cancel them out, or we can just keep playing with it. Let's subtract the 6x squared from both sides. So you get negative 6y dy dx is equal to negative 6x squared. Divide both sides by negative 6y. Okay, I lied, so we are going to get y in the denominator. So dy dx is equal to x squared over y. There's our first derivative. Now for our second derivative, we're going to cheat. Dy dx, because honestly, I would rather do a product rule than do a quotient rule. Dy dx equals x squared times y to the negative 1. Nice little product rule going on. So u equals x squared, u prime equals 2x. V equals y to the negative 1. So v prime is going to be negative y to the negative 2 dy dx. And we're doing a u prime v plus v prime u. So multiply this way, we get 2x y to the negative 1 minus, the minus is coming from this guy right here, x squared y to the negative 2 dy dx. Now do keep in mind this is the second derivative. So yes, I would like you guys to clean it up, but I can look at this and know if you did it right or not. Now keep in mind what dy dx is. That's x squared over y. So we're going to clean this up a little bit. So I have 2x over y minus x squared over y squared times dy dx. But dy dx is x squared over y. So this guy has y cubed, but this guy has only y. Change color of pens. Why? Because I can. Multiply top and bottom by y squared. That way I have a common denominator. So in the end, I get 2x y squared minus x to the 4th all over y cubed. And don't forget that that is your second derivative, so you need to write it as d2y over dx squared. Now I could have left this one as a quotient rule and done a quotient rule. It still would have came up with the same answer. Okay, x squared plus 2x. Oh, don't forget this y squared in front. So y squared equals 2y dy dx equals 2x plus 2. Divide both sides by 2y. And we get dy dx equals 2 times x plus 1. I will point this out why I did this. Notice they both have a factor of 2, so I factored it out. 2x, 2 times 1, 2. That way I can do this. So my first derivative is x plus y all over, x plus 1 all over y. So second derivative. So we have x plus 1, u is equal to x plus 1, so u prime is 1. V equals y, so v prime is dy dx. It's quotient rule, So u prime v minus v prime u all over v squared. So u prime v is just y minus, multiply this way, I get dy dx times x plus 1. And this is your second derivative, so d squared y over dy squared. There's that dy dx, and we know that to be x plus 1 over y. So this is going to be y minus x plus 1 over y times x plus 1. Okay, there's that change of pen time again, because I have a denominator y over here, but not over here. And did anybody notice that I forgot my v squared part? There. So this guy is going to become positive because or squared because I'm going to get a common factor. All of this is over y squared. So now I have a common factor of y here, so I can bring the y down to make it y cubed. So in the end, my d squared y over dy squared is going to become y squared minus x plus 1 squared, x plus 1 times x plus 1, all over y cubed. Because the common factor here is y, and so my common denominator can be brought down with the denominator. Now, the question is, does that look like anything like our problem? Nope. I have a y squared. I do have a y squared, so I can put in x squared plus 2x here, and we can clean it up a little bit, which will take a little bit more time, but we do have y squared equals x squared plus 2x. So let's clean this up. X squared plus 2x minus, multiply that out, we're going to get x squared plus 2x plus 1 all over y cubed. Distribute the negative, we get x squared plus 2x minus x squared minus 2x minus 1 all over y cubed. X squared is going to cancel out, the 2x's are going to cancel out, and we are left with negative 1 over y cubed. If you had to do your third derivative, that would be a much easier problem to deal with. Okay, again, the point that I want to make sure it gets across is that this is a legitimate derivative. They said find the derivative, there it is. You cannot leave it in this format because you have a dy dx. You have to, everything has to go back to the original variables. So when I got rid of the x squared minus 2x, that's fine. I got rid of my x's. So if I had to do the third derivative, I'd only have y involved. Okay, and then our last rule is something I think you guys have already been playing with, power rule for rational powers. Notice it hasn't changed. It's for n is less than 1, then the derivative does not exist at x equals 0, which is fine. So the when n is less than 1. So anyway, but this is stuff that you guys have been working with before, and I know that our video is already at 30 minutes, very long, but just a couple of these problems to play with. X to the 1/2, just rewrite it, so I have y equals x to the 1/2, so dy dx, power rule, 1/2 x to the 1/2 minus 1. 1 over 2 minus 2 over 2 equals negative 1/2. So we get 1/2 x to the negative 1/2, or 1 over 2 square root of x. And yes, you are leaving it as such. Dy dx equals 1 over 2 square root of x. You do not have to rationalize your denominator. Okay, this one they already wrote it for you. It's great. X to the 2/3. So y prime equals 2 over 3. X to the 2 over 3 minus 3 over 3. Keep that in mind. All you have to do is write it with the same denominator, top and bottom. 2 minus 3 is 1, so we get y prime equals 2 over 3, x to the negative 1/3. This is the reason, that's fine, you want to leave it like that. Or you can rewrite it as 2 over 3x to the 1/3 power. This is fine. And then this one is going to be the chain rule. They did the power thing here with the chain rule. So the derivative of the inside, sine of x, actually negative sine of x. And then the derivative of the outside gives you negative 1/5 times cosine of x. And don't forget to subtract. Negative 1 over 5 minus 5 over 5 gives us negative 6 over 5. So I get sine of x over 5 times cosine of x to the 6/5 power. And there you go. That's fine. We can leave it as such. Yeah, we can play with trig a little bit on this one, but then we'd have still 2 trig functions. Okay, so there's that one is. Again, I apologize for that one being really, really long. I didn't expect it to be so long, but good luck in your endeavors there.